All right, today we're diving into a shift that's, well, it's so profound it could literally redefine our entire digital world. We're talking about moving the very heart of the internet, our data centers, from right here on the ground up into the stars. So, why this crazy, monumental change? Well, it all comes down to a really simple but urgent question. The AI revolution is here. It's booming, right? But its insatiable hunger for power is just gobbling up resources and pushing our planet's infrastructure to the absolute breaking point. You could say we don't have a big enough plug. And if you want to put a number on that hunger, just look at this. By 2026, we're projecting AI will need 1,000 terawatt hours of energy every single year. I mean, to give you some perspective, that's more than what entire countries like Sweden or Argentina use in a year. A number that big, it's just staggering. And it basically tells us that the old way of doing things, yeah, that's just not going to cut it anymore. Okay, so the obvious question is, why can't we just keep building more data centers right here on Earth? Well, it turns out we're walking right into what you could call a perfect storm of problems. A whole bunch of constraints that are grinding that traditional expansion to a screeching halt. You see, the core problems are all tangled together. First, our power grids, they're already maxed out and we're looking at huge shortfalls. Then you've got land and water scarcity. I mean, Microsoft literally had to cut back its water use in Iowa just to keep one data center cool. And the costs? They're just skyrocketing. We're talking over 10 times billion dollars for a single campus now. And on top of all that, you have to deal with regulations, carbon taxes, and people just not wanting these things in their backyards. It's become a complete and total bottleneck. So, with Earth pretty much hitting its limits, where do we go? The answer, believe it or not, is up. Yeah, we are looking at one of the most audacious, almost sci-fi solutions you can imagine, taking our data centers and literally putting them into orbit. And the scale of this vision is, well, it's just mind-bending. Get this, SpaceX has filed to launch up to 1 million solar-powered satellites, each one acting as a little piece of a giant orbital computer. Think of it like a cosmic cloud. These satellites are like nomadic neurons, all working together to form a kind of global brain, floating in the sky. Okay, now this is where it gets really interesting. Look at how this table just perfectly lays out the two approaches. For every single problem we have down here on Earth, power, land, build time, you name it, space offers an almost perfect solution. It's not just an improvement, it's a completely new paradigm. So really, the crucial point is this. At the end of the day, it all boils down to one thing: energy. Down here, we're fighting tooth and nail for every single watt from a grid that's already strained. But up in space, you've got access to unfiltered, unlimited solar power 24/7. That right there is the fundamental game changer. All right, so let's move on and see how this actually builds from a cool sci-fi concept into a real engineering project. What are the core technologies that make an orbital data center even possible? First off, like we said, it's all about the power. A solar array up in orbit with no atmosphere to get in the way and no nighttime, well, it's a whopping 5 times more efficient than the best panels we have down here. That massive energy advantage is what drives this whole idea. So how does it actually work in practice? Let's walk through it. Step 1, data gets beamed up from Earth. Step 2, all the heavy AI processing happens up there, across that swarm of satellites. Step 3, the information gets passed between the satellites at incredible speeds using a laser mesh network. And finally, Step 4, the results are delivered back down to us anywhere on the globe. Now, there are a few key technologies that really make all this feasible. You've got radiative cooling, which is brilliant. It uses the vacuum of space to get rid of heat without needing a single drop of water. It's like using the cold of deep space as a giant free radiator. Then there are the laser links, zipping data between satellites at 200 gigabits per second. But honestly, the real secret sauce, the thing that makes the economics work, is Starship. It promises to slash launch costs down to just $10 a kilogram. That's what makes this whole thing affordable. But you know, this isn't just a SpaceX story. This whole vision has kicked off a brand new global space race. And like any giant leap forward, it comes with its own set of pretty significant challenges that we still have to figure out. And believe me, this race is already getting crowded. In the US, you don't just have SpaceX. You've got Google and Blue Origin jumping in. Over in China, Ada Space is planning its own constellation. And Europe is right in the mix with companies like Thales Alenia Space. Yeah, the competition is definitely heating up fast. Now, all this ambition comes with a pretty massive risk. I mean, we're talking about adding up to 1 million new satellites up there. That brings up the very real, very scary danger of something called Kessler syndrome. It's basically a runaway chain reaction of collisions that could fill orbit with so much junk that space becomes completely unusable, maybe for generations. And it's not just collisions either. There are other huge technical hurdles. For one, getting rid of all that heat requires massive radiators. Then you have cosmic rays, which can cause 1,000 times more data errors than we see on Earth. And even though that laser mash is super fast for satellite-to-satellite communication, getting all that data back down to the ground, that's still a major bandwidth bottleneck we have to solve. Okay, so let's say we overcome all these hurdles. What does this all actually mean for us back here on Earth? Let's bring it all home and take a look at how this cosmic computing era could really reshape our world. Wow, the projections are pretty incredible. By 2030, orbital computing could be handling nearly a third of the entire global AI workload. Think about that for a second. This wouldn't just be adding a little extra capacity, it would fundamentally change the game, taking immense pressure off our planet's power grids and resources. And this timeline here illustrates the disruption perfectly. In just the next couple of years, we'll see the first prototypes go up, which will probably freeze the growth of new data centers on the ground. By the early 2030s, we could see new Earth-based construction get cut in half. And after that, well, orbital could just become the new normal, with the data centers down here serving more specialized, niche roles. It really points to a future where we stop looking at the stars as just a frontier to be explored and start seeing them as the next great industrial domain, a factory floor for the fuel of the 21st century, which is, of course, data. So at the end of the day, the question really isn't if our digital world will move into the cosmos. It's who's going to control it when it gets there.